everyone, it's Miss Cress. I am going to go over with you how to predict your products from the 5 different types of chemical reactions. First step is to identify your 5 types of chemical reactions. So let's go with the first one, which is our oddball, which is a combustion reaction. And combustion reactions always start with 2 reactants, and the first reactant is always a hydrocarbon. You can tell it's a hydrocarbon if it has carbon and hydrogen in it. And the other reactant is always oxygen. The second type of chemical reaction is going to be your synthesis reaction or your combination reaction. Combination reactions or synthesis reactions always start with 2 elements. So let's just say we have element 1 and element 2. The opposite of synthesis is decomposition. Decomposition reactions always start with 1 compound. Single replacement reactions are going to have a single element, single reaction, single element, and a compound. And last, double replacement. Double replacement is always going to have a compound plus another compound. Now, why is combustion so easy? Because when you're predicting products, predicting products, it's always going to have the same 2 products, which is always going to be carbon dioxide and water. Now, when it comes to synthesis, because you have 2 elements, those 2 elements are going to crisscross together and create a single compound. Because decomposition is the opposite of synthesis, it means it's going to break into 2 things. Now, those 2 things could be an element and another element, or it could be an element and a compound. Most of the time, I'm going to try to give you these ones because that's the easiest one to do. For single replacement, when it comes to your element and your compound, you're always going to end up with this element replacing something in that compound and then kicking another element out and creating a brand new compound. For double replacement, we have something from the first compound replacing something in the second compound and vice versa. So what you're going to end up having is 2 more compounds. Now these 2, it makes more sense showing you an example of that, and that's what I'm going to get to next, is showing examples of all. So these 3 equations are the same type of equation. Now notice that you have an element plus another element for each one of these. So an element plus another element is going to be a synthesis reaction. So what do you do with a synthesis reaction? Well, the first thing is I always go through and I look at each one of my elements and I try to figure out what is the charge of that ion, because what's going to happen is we're going to crisscross those ions over here to create our single compound. So magnesium is a +2, iodine is a -1, calcium is a +2, nitrogen is a -3, potassium is a +1, and bromine is a -1. So up here, I know I have to have a compound that is magnesium crisscrossed with iodine. And when you end up crisscrossing that, you end up with MgI2. For this next one, we have calcium, which is +2, nitrogen, which is -3. You crisscross those, you end up getting Ca3N2. For this one, potassium's a +1, bromine is a -1, crisscross those, you don't write ones, and you end up with KBr. Now notice for our synthesis reactions, we have our 2 elements as our reactants, and then we yield 1 product, and that 1 product is a compound for every single one of these. Now for these next 3 examples, we have 1 single reactant. Notice that it's going to be the opposite of what the synthesis reaction is. Where synthesis is creating 1 compound, the next type of reaction starts with 1 compound and is going to break down into 2 or more things. When we notice that we only have 1 reactant, that's when you can tell that this is a decomposition reaction. So for this one, there's no crisscrossing, it's actually breaking these in half, but we need to break them into their two separate elements. So we have sodium chloride, which you're going to have sodium, and you're going to have chlorine. For this one, we have aluminum oxide, we have aluminum, we have oxygen. Now, this one right here, I'm gonna wait until a little bit later after I do these two, because this one's a special one that you guys should know off the top of your head from all the stuff that we did in class. Now, I'm gonna look at my elements here, and the next question you are going to ask yourself are there any Brinkelhoff buddies here? Now remember, Brinkelhoff buddies, if they are by themselves, are going to have a little subscript 2 with them. So out of sodium and chlorine are either one of those Brinkelhoff buddies. Yes, chlorine is a Brinkelhoff buddy, so that means I have to put a 2 there with chlorine. Aluminum and oxygen. Is aluminum? No. Is oxygen? Yes. So I have to put a little 2 with that one. So now that we have our equations written correctly here, I'm going to come back down here. This is hydrogen peroxide. We've done a demo on this. We've used this several different times in class. You guys should know that hydrogen peroxide is going to break down into two things. First thing is that it's going to break down into water, and it's going to break down into oxygen. Again, oxygen is a Brinkelhoff buddy, so it gets a little 2 with it. For this next set of 3 examples, we have for our reactants an element and a compound. A single element and a compound. Because I'm focusing on the single element with a compound, this is going to be your example of single replacement. So, how do we know if that single is going to replace the element in the compound? Well, again, we have to look back at our activity series. So first off, metals will replace metals. So here's potassium, here's calcium, here's aluminum, here's copper. Now, hydrogen likes to act like it's a metal because it is a cation, it has a +1 charge. So I need to see, is sodium higher than hydrogen on the activity series? Is potassium higher than calcium on the activity series? And is aluminum higher than copper on the activity series? If any of our elements are not higher than the one they're trying to replace, the reaction will not occur. So I need to look at something like this little handy activity series that I pulled up and see if these are going to happen. So sodium and hydrogen. Is sodium higher than hydrogen on the activity series? Yes, absolutely. Sodium is the second one down on the activity series, and hydrogen's all the way down here. So we need to figure out what our charges are again. Sodium is a +1 charge, hydrogen's a +1 charge, and chlorine is a -1 charge. This one's going to be pretty simple. So sodium is going to take hydrogen's place. So I need to put sodium with chlorine. I get sodium chloride, NaCl. And then I have hydrogen by itself. Now remember, hydrogen is a Brinkelhoff buddy. So that means that hydrogen is going to need a 2 with it. All right, so let's look at our other guys here. We need potassium and calcium. Is potassium higher than calcium? Let's look again. Oh, look at that. Potassium's all the way at the top and calcium is right down here. So yep, this one's going to happen too. Again, figure out your charges. So potassium's a +1, calcium's a +2, and hydroxide is a -1. So my potassium, K +1, is going to go with my hydroxide, which is OH -1. Here we have potassium hydroxide, and then I'm going to be left with calcium by itself. Now, calcium is not part of the Brinkelhoff buddies, so calcium is just left by its lonesome, doesn't need a 2 or anything else. Last, aluminum, and copper. You guys should know if this is going to happen because this was in your, what was it? Our lab that we did. So aluminum with copper 2 sulfate. Is aluminum higher than copper? Look here. Aluminum is right here and copper is all the way down here. So yep, this one's going to happen as well. So again, get our charges and then we're going to crisscross. So aluminum is going to go with sulfate, so SO4 minus 2. So we have Al2, SO4, 3. And then our lonesome person is going to be our copper. That was that rust colored kind of powder that you guys had at the bottom of your test tube. And again, copper is not a Brinkelhoff buddy, so copper just is left by itself. For our next 3 examples, we have 2 reactants that are compounds. So the only thing that we can get out of these types of reactions are 2 more compounds. This is why these examples are examples of double replacement. Okay, so double replacement, not really hard, but you have to figure out what all of your ions are to begin with. So here I have a polyatomic. This is ammonium, which is a +1 charge. Chlorine's a -1 charge. Calcium is a +2 charge. Cyanide is a -1 charge. So in order to do this, we have our cations replacing each other. That's just the way that I always do it. So my ammonium ion is going to bond with my cyanide ion over here. So that's my first one. So I have a +1 and a -1. So I end up with NH4CN. Looks complicated, whatever. Next, I have to do my other compound. So I have calcium, which is a +2, and I have chlorine, which is a -1. Crisscross those, and you get CaCl2. Oh, sorry about that. Yeah. For this one, we have potassium being a +1, and nitrate being a -1. Over here we have barium being a +2, and nitride being a -3. Again, we are going to take our cations and we're going to flip-flop them. So potassium is going to go with nitrogen. So if you crisscross those, we end up getting K3N. On the next one, we need barium going with the nitrate ion, so NO3 -1. If those crisscross, we have Ba, NO3, 2 on the outside. Last one, again, sorry about the mess up here, don't have my whiteout that I have at school. And we are going to flip-flop our cations. Calcium is a +1, carbonate is calcium is a +2, carbonate is a -2, they canceled out. Strontium is a +2, and chlorine is a -1. Again, we're going to have our calcium, which is a +2, go with our chlorine, which is -1, CaCl2. And then we have our strontium going with our carbonate, CO3, -2. Squeezing in there. Again, +2, -2, they cancel each other out, so we end up getting SrCO3. So last but not least, we have our 3 last examples. Okay. Turn down my music a little bit there. All right, so we have a compound and we have an element, but do not be fooled. This is not a single replacement reaction because we have a special compound, which is a hydrocarbon, has hydrogen and carbon in it. And our other reactant is oxygen. So absolutely, these 3 are your examples of your combustion reactions. Now, combustion reactions, easiest ones ever because you don't have to do any crisscrossing. You just have to remember that for a combustion reaction, you have carbon dioxide and water as your only 2 products. So fill it in, and you have just figured out or listened to how to predict products for all types of reactions.